GameSci.com. Hello, it's me, Professor Chris Ferguson, ready to school you on some classes and objects. Classes and objects. A class is to an object. This is like that old SAT question. A class is to an object, like a blueprint is to a house. In order to create a house, first you need a blueprint, a detailed set of instructions telling you how to create a house. How many bedrooms, how many bathrooms, where the kitchen is. A blueprint is a set of instructions for building a house. Well, that's what a class is. It's a set of instructions for how to build an object. Like a recipe is to a cake. What is a recipe? It's a list of ingredients and a set of instructions. You get the ingredients, you follow the instructions, and boom, you've got a cake. What is a class? It's a list of variables, a list of functions. You put them together, boom, you've created an object. Can you declare a few variables? Now you'll have to do it inside of a special function, but all you have to do to create a class is create a few variables inside a function. Can you write a few functions? Although we're going to call them methods now. A function inside of a class/object is a method, but you've been writing functions up to this point. You should be able to write a few functions by now. That's all you need to do, people. Create a few variables, create a few functions, and boom, you've got a class. In a Python program, you have to create a class. Here is our class enemy, followed by a colon, and of course, everything after the colon is what? Indented. But that's all you got to do to create a class. You learn one word, class. Couldn't be more literal. You do have to name your class, and as with variables and as with functions, give it a good descriptive name. The name of the class should match the thing they're trying to build. Here in this program, we're going to try and create an enemy class, something that we battle during a video game. The next thing you need to do when creating a class is to declare or create some variables. Now there is a special way you do it when it's inside of a class, and we'll talk about that later. But you create some variables at the top of your class, and those variables become the variables that are part of your object. Next, you have to write some functions inside of a class. Notice how these are indented. In order to be part of the class enemy, it has to be indented under the class enemy. We've written plenty of functions in this course. All you have to do is write them inside the class. You create some functions inside the class, and boom, they become methods of your object. And that's all a class/object is. It's a set of variables and a set of methods inside a class, so they become part of your object. I wrote a special line of code down here. This is the end of the indent. That will mark the end of class. Python is very consistent. You indent when you're creating something. As soon as the indent stops, the class is over. And anything inside the class definition, meaning it's indented under the keyword class, will be part of your object. And anything that follows that is not indented will have nothing to do with your class, nothing to do with your object. Just like an if statement, if it's not indented, it's not part of the if statement. Just like with a regular function, if it's not indented under the DEF, it's not part of the function. As soon as the indentation stops, the class is finished. Let's go back to this relationship of a class to an object. You're typing in your code. If you're typing in your code, I guarantee you're working on the class. You then run your program. When you run your program, you create objects. Objects are a runtime entity. If your program is not running, you're working on the class. If your program is running, then maybe, if you've created an object, you're dealing with the object. I must stress, an object is a runtime entity, and any variables that you created inside your class will be the variables of your object. And any functions you wrote inside your class will be the methods that are part of your object. We call them functions when they're outside of a class/object. We call them methods when they're inside of a class/object. There's a brief overview of how classes and objects work together. Let's move on to write a class. Writing a class. Up until now, we've been using the Python built-in classes. There is a built-in class str, which stands for string, which allows us to build string objects. There is a built-in class list, which allows us to build list objects. Now has come the point when we need to write our own classes so we can build our own custom objects. Let's look at writing a class. As stated before, we need the keyword class, followed by the name of the class. Be sure to give your class a descriptive name that describes the thing that you're building. We are building an object that we will do battle with during a video game, so we will call this the enemy class. Python is nothing but consistent. Whenever you develop code that has to be indented, it will be preceded with this colon. This colon says we are going to indent the code below, and everything indented below will be part of the class enemy. As soon as the code reaches a point where it is not indented, that's the end of class enemy. That's why I drew a box here and a box here. That's the official start of class enemy, and this unindented line of code is the official end of class enemy. Anything between these two boxes will be part of the class and part of the object. Anything outside those boxes is not inside the class and will not be part of the object. Variables, aka properties. You'll see that we create variables slightly different than we have before. It does require using this self parameter, and we'll explain that shortly. And it does require that we put them inside of a function, a special function called underscore underscore init underscore underscore. This is called a constructor function, and you don't have to put them in this method, but I always recommend putting these in the method and put them at the top of your code. Please, please, please create your variables at the top of your code. That is the one place we will look and find them every time. If you scatter your variables throughout the class, they are difficult to find. Inside init, please create your variables. These are the variables that will be part of your object. A more object-oriented term for variables in this case is called the properties. Just like we call a function a method when it's inside of a class, we like to call a variable a property when it's inside of class/object. Functions, aka methods. This is the definition of the setExposition method, also called a setter or set method. This is the definition of the getExposition method, also called a get method or a getter. These are two methods that allow you to insert new values into our object and retrieve a value from our object. Well, technically, init is just another method. It is a special method. It's called a constructor in other computer programming languages. Init is a special method that constructs or builds objects. Whenever you create an object out of your class, the first method that runs, and it runs automatically, is the init method. That's why we like to create our variables inside of the init method, because they get created at the very beginning. As soon as you create an object out of the class, these variables will be created. In other computer languages, this is called the constructor method. In Python, we call it the init method, but it's the equivalent of a constructor. Setters are methods that put values in objects. The reason you build a set method or a setter is to insert new values into the variables of the object. Getters pull values from objects. The reason we create a get method is so we can extract one of these values from our object. Setters put values into the object variables. Getters pull values out of the object variables. A class creates a new variable type. Let's run some code to create an object. The class is the blueprint for an object. What do I mean by a class creates a new variable type? Well, we know about the int variable type, and we know about the string variable type, and we know about the float variable type. Whenever I create a class like class enemy, I am basically building a new variable type. I can create a variable of type enemy when I create an object out of the class enemy. Let's trace this code and see what happens. We'll build an object, and then we'll use the object to manipulate the data stored in the object. Object equals enemy. Let's make this perfectly clear. Object is what we call a reference variable. We will not store the variables inside of object. What gets stored inside of object? A reference to the object that will contain these variables. Object is a reference variable. Object equals enemy. This is the line of code that creates an object out of our own custom class. When I create the new object, it will automatically call init. And when it calls init, it will set the self variable equal to object. What do I mean by that? The variable object is a reference to this object in computer memory. When we say self equals object, self becomes a second reference to that same object. At the time this code runs, self and object will be referring to or pointing to the exact same object in computer memory. Execute the code in the init constructor. Init says self.xPosition equals 0. We'll look at self. Self.xPosition will insert a 0 into the object variable xPosition, or xpos. What you'll notice is when it installs it into self, it is also setting object's xPosition. Self.ypos, or yPosition, equals 0. Once again, we'll go to the self reference variable, access what's in the self reference variable, and the ypos variable will be set to 0. At the same time we're doing that, we're setting object's ypos. Because object and self are pointing to the same thing, anything I change in self is changing this object variable. Self.health equals 100. Again, I go to the self-reference variable, access the health variable within it, and 100 is assigned to my object variable health. Since self and object are pointing to the same thing, I am populating the variables inside of this object reference. When we return from the init method, you can definitely see that our reference variable is tied to or pointing to this object in computer memory. The variable object is a reference to an instance of class enemy. Keep in mind this code is outside the class, it's running, it created an object, and now it will use that object. Object.setXPosition, passing it the value 50. Whenever you use an object reference to run a method, it automatically sends a copy of the reference to the method. See this self equals object? When I execute a method, it will automatically set the value of this parameter to whatever object executed that method. In this case, we also have an argument 50, and the value of the argument 50 will be assigned to the next parameter in the method. X will be set to the value 50. Does everyone see that? When we invoke a method, self automatically gets set. Arguments get set to the parameters. This is a very important point. Self equals object, X equals 50. When you start executing this method, self will be pointing to the same object as the reference used to call the method. At this point, self.xPosition and object.xPosition are the exact same thing. Setters put values in object. A setter method would need access to the reference variable to get to the object variables. Self.xpos equals x. X contains the value 50, so a 50 is inserted to xpos. I cannot stress enough, this is just like saying object.xpos equals x. When we execute self.xpos, it would be the exact same thing as if we executed object.xpos. Self and object are pointing to the same thing. Anything I do to self will happen to the object reference variable. Let's go back out and execute the next line of code. X equals object.getXPosition. When we invoke a method using the object reference, we will set self automatically to the same reference. What does that mean? Self will point to the same thing that object points to. That's what that means. Getters pull values from objects. This time we will extract a value from the object and send it back to the caller. With self equal to object, you can see that self is pointing to the same thing that the object reference variable is pointing to. So whatever we do from self, it's coming from the object reference. Return self.xpos. Return value 50 to be assigned to the variable x above. At the time this code executes, it will have extracted this 50 using the self variable. It will extract this 50, send it back to the caller with the return statement. What happens when it returns? It assigns it to the local variable x. Here it is. Whatever this method returned, I will assign it to the variable x, and our 50 shows up here. Objects are not much more complicated than that. You build an object, you put some stuff in the object, you pull some stuff out of the object. That is how we use objects. However, before we can use our own custom objects, what do we have to do? Define our class. We create a class in order to be able to build objects out of that class. That is a pretty simple version of our first class. But as they get more complicated, the only difference is you'll probably create a few more variables here, and you'll definitely write more functions. But that is all a class is. A set of variables that we create inside of init, and a set of methods that operate on those variables. And voila, you've built your own class. Now you can build custom objects out of your own class. Class design. To create a class/object, you need to come up with a set of properties and methods. Variables and functions, in other words. You need to design a class before you type in the code. I like to write two lists while I'm designing a class. I sit down and ask myself what the object is. The information that best describes the thing I'm trying to build. That's the variables or properties of a class. The second list I create is what the object does. What are the things or actions I want my object to perform? Well, that's the function/methods of a class. Once I know what the object is, I can create the variables. Once I know what the object does, I can create the methods. Well, all a class is a set of variables, we call them properties now, and a set of functions, we call them methods now, and voila, I've built a class. Let's create the class map object. We need the keyword class. Of course, we need our colon at the end. And then everything that is indented below the colon after the keyword class will be part of our class map object. As soon as the indent stops, that's the end of the class. What a map object is. What data describes a map object? The information that describes the thing we're trying to build, a map object, will define the variables we want to create. I came up with this list. We need a type of the map object. We need a value for the map object. And we need an isGood flag. IsGood true means it's a good thing. IsGood false means it's a bad thing on the map, something we don't want to pick up. As the player character or PC moves on the map, these objects sit on the grid and can be picked up. Like a healing plant, where isGood is set to true and adds to the playing character's health. Or a poison plant, where isGood is false and it subtracts from the playing character's health. This is the information I need to describe my map object. That defines the variables I'll create in the map object class. Let's describe these in detail. The type of the map object. The type of the object should match the game. For a Harry Potter/magic type game, we'll have things like healing potions and poison potions, strength spell and strength drain, wand boost and wand wrecker. Ooh, that's hard to say. Wand wrecker. A wand boost will give your wand more power. A wand wrecker will take away power from your wand. These are things you encounter on the map. Some of them are good. They boost your health or strength values. And some of them are bad. They subtract from your health or strength values. The type determines what we're putting on the map. The value of a map object. The value variable/property is the amount to add/subtract when the PC and this object collide on the map. when the PC lands on the same square as this map object, how many health points do you get? Or how many health points do you subtract? Note how generic this class is. There is nothing specific about a specific game or category of games. It could be used in a fighting game, or a magic game, or a fairy tale game. What we don't want to see in our map object class is anything specific to the type of game we're playing. That will be provided as a parameter when we set the type. When the isGood variable / property is true, we will add when the PC and this object collide on the map. When it's false, we will subtract from the health or strength. When isGood is set to true, we will definitely want to pick this thing up. But this class is generic enough the programmer using it could use the object and its variables any way they want that best fits their game. I'm trying not to be specific to a particular type of game inside this class, so I could use it in many different games. That's an important goal of class and object design. You do not want to tie this directly to the type of the game you're building. I put this isGood flag in there because that's how I'm going to determine whether I'm adding or subtracting. But someone who's using this doesn't have to pay attention to this variable. They can decide based on the type and value what to do. What does not belong in a class? The variable should describe what the object is. Something named temp does not describe a map object. I put this in here just for a short period of time to show you the type of variable you would not put in this class. First of all, temp is very generic and has nothing to do with a map object. The variables inside of map object should describe a map object, and there should be no other variables, especially not one that is so generic and has nothing to do with a map like temp. I can always spot a beginning object-oriented programmer because they create all these variables inside their classes that have nothing to do with the object they're trying to build. Keeping on the topic of the variables are created in the init constructor. Variables should be the core information that describes what the object is. Now I determined type, value, and isGood would be the most important information to describe a map object. What if I was building a car class? A car class, the make, model, and year would be important information that describes a car object. Those would be the variables of the car class. What if I was building a book object? A book has a title, an author, a number of pages of the book. This is the core information that describes a book. That should define the variables that you create in your constructor. The init constructor should create these variables, the core information that describes the object you're building. Any extra variables, especially fluffy ones like temp or data, they should be outside of the class. They should be local variables, not object variables. Recall when I talked about global variables. Only the most important information needs to be stored as a global variable. Now with object variables, only the important information that describes the object you're building should be created in the properties or variables of the class. Variables are only half of an object. What a map object does. What actions does a map object perform? This is the second list. The first list is what the object is. That defines your variables. The second list is what the object does. That's your methods. First of all, we need to create map objects, and that's why we should add an init method at the top of our class. The second thing we want a map object to do is return the type of object, maybe for display, maybe for processing, but we need to know the type of the object. That is the thing a map object should tell us. Return the value of the object. And I put a plus minus here because if it's a good object, this is the value we want to add to our strength or health. If it's a bad object, we want to subtract. So we return a value from the map object to let us know whether we should be adding to our strength or health or subtracting from our strength or health. If this is the list of things that I want my map object to do, then those are the methods I need to write. Let's look at these methods in detail. We need a method to create a map object, so we have to create an init method. The job of the init method is to create the variables and initialize them. In this particular case, I decided to pass in as parameters the values that we want to initialize with. So when I call the map object constructor, I will provide it a value for t, and that's the type of the map object. I will provide a value for v, and that's the value of the map object. And I will provide a value g, that is the isGood value of the map object. That's what constructors do. They create the variables and they initialize them. Here's a getter method that returns the type of the map object. It will send back or return to the user the type from the object variable. Return the value of the object +/-. Here's where the isGood variable is used. If the value of isGood is true, we want to return a positive value. But what if isGood is false? It's a poison plant. It's an energy drain. Then we take the negative value and send that back. So if value is 10 and it's a good thing, we'll return a 10. But if the value is 10 and it's a bad thing sitting on the map, we'll return -10. And the reason for making this negative is so I don't have to have two sets of code outside of the class. If it's a bad thing that I picked up and I add the negative of value, it'll subtract from my strength or health. To summarize, the list of the things the object is defines the properties/variables of the class. This is what describes a map object. Those are the variables I need to create. The list of things the object does defines the methods/functions of the class. This is a list of things I want my map object to do. Therefore, that's the methods or functions I need to write inside my map object class. In wrapping this up, it's important to emphasize you need to think about the class/object you're building. Before you start typing your code, decide what this object is, and that'll tell you the variables you need. Before you start typing in the code, decide what the object does, and that will tell you the methods you need to write. Hidden variables, aka private variables. In Python, we call these hidden variables. Other computer languages might call these private variables. The __ in front of a variable specifies the access mode of the variable from outside the class as hidden or private. If you look at __ with, this is a hidden variable. If you start the variable name with 2 underscores, Python will hide this variable from the user of the class, the objects created from this class. The lack of 2 underscores means everyone will be able to access this variable. This is called public access in other languages. Height is a non-hidden or public variable. Notice there's no underscores in front of height. Everybody that creates an object out of class map is going to be able to access this height variable. Hidden means very restricted access. No one outside the class can directly access the hidden __ with variable. In Java or PHP, we'd call these hidden variables private variables. In Java or PHP, we'd call these non-hidden variables public variables. What you need to know is hidden variables can be accessed inside the class without a problem. I clearly marked the end of class map to show you the code inside the class. If you are between the keyword class and the end of class map defined by the end of the indentation, if you're inside the class, you have full access to anything that's hidden. It is code outside the class that creates objects from the class that is restricted. Here I wrote a little snippet of code that creates an object out of class map. If you create an object out of class map, you will not be able to access the with variable. When you have 2 underscores in front of a variable name, you are not allowed access to the hidden variable. However, if you have a variable that doesn't have the underscores, object.height, you will, yes, be able to access this variable because it's not hidden. This code right here would be code that executes from outside the class, even if it's in the same file. If you are not between the colon and the end of the indent, you are outside the class. If it's not between these two red boxes, you are outside the class. This code is not between those boxes. It has no access to the hidden variables. On the left side, the code inside the class can access the hidden variables no problem at all. You see here on the left, this is the code inside the class. We created the hidden variable underscore underscore width, and inside the class, we're using the variable underscore underscore width. We're using the variable underscore underscore width. Inside the class, the indented code below class map, we can use the hidden variables. In other words, it's not hidden from us, it's our variable. On the right, code outside the class will not be able to directly access the hidden variables. This is code outside the class. If I try to get to underscore underscore width, it'll be an error. If I try to use underscore underscore width outside the class, it'll be an error because it's a hidden variable. Hidden versus non-hidden determines what the reference variable will be able to access directly. Again, this is just a question of access. It's not does it exist or not exist, it's do I have access to it. Since world is outside the class, it cannot see the hidden variable underscore underscore width, but it can see the non-hidden variable height. All the underscore does is say who has access to it. With the underscores, outsiders like world will not have access to it. Without the underscore, full access is granted. This line of code creates our map object. In our map object world, you can see we have the underscore underscore width. It's set to 0. We have the height variable. It's set to 0. What's the big difference between these two variables? Insiders only have access to width. Insiders and outsiders have access to height. So let's show you what's not allowed. In fact, this code won't even compile. I'm going to go to the world reference variable and go inside of it and try to access a hidden variable, something that starts with 2 underscores. And what I'll get is a big fat error. Access mode hidden means code outside the class cannot directly change or access underscore underscore width. This would be a syntax error. Python would light this up in red and say, I won't even allow you to run this code. It's an error. But what can I do? I can call a setWidth method. I'm going to use the world reference to call the setWidth method and pass it a 20. This would mean self would be equal to world and w would be equal to 20. However, by calling the method setWidth, you can request to change the hidden width variable. This is allowed. Instead of directly changing the underscore underscore width variable, I'll call a method and ask the method to change the width variable to 20. Notice that the self reference is pointing to the same object as world is pointing to. First thing I'll do is check out my w parameter. SetWidth is a setter method, a method designed to change the value of a hidden variable. Notice how a proper setter verifies the input. We'll look at what the user is asking us to change the width variable to. W contains the value 20, so we're really saying 20 greater than or equal to 3, that is a true statement, and 20 less than or equal to 25, that is a true statement. When you add two trues together, you get a true value. In other words, what we just verified was W is a valid width value. And as a valid width value, we will go inside the if statement and execute the code inside the if. Self.__width equals W. And the 20 that was passed in the parameter W is assigned to the hidden width variable. Since the input parameter W was good, the setter goes ahead and changes the value of the hidden variable __width. Inside the class, we have full access to __width. A good setter will always verify the values before it assigns it to the variable. What this setter did is said, I want to make sure the width is restricted between 3 and 25. If it's less than 3, it's not good. If it's greater than 25, it is not good. You pass me a good value, and I will change the hidden variable. WID equals world.__width. This is another error. Why is this an error? Because I'm trying to directly access from outside the class the width variable. Access mode hidden means code outside the class cannot directly access the value in the __width variable. Again, this would be a syntax error. Python will not let you run until you fix this line of code. Now, how do I fix that line of code? By calling a get method. Instead of directly accessing the width variable, I will go to the world object reference, call the getWidth method, and ask it to return the width of this map. When I call a method using the world reference, self will be assigned the value of the world reference. What will happen here is, you know that object the world is referencing right there? I want self to reference the same object. And self will automatically be assigned the same reference as world. Inside the code, when I go to self.__width, remember, I'm inside the code, so I have full access to my hidden variables. I'll grab that 20 and send it back to the caller. The method will return the value 20 in the hidden property __width to the code outside of the class map. After the value is returned, it will be assigned to our local variable WID, and there's the 20. The return value is a copy of what is stored in the hidden variable __width. See that 20? We made a copy of it and sent it back to the caller. This is a copy. At that point in time, this is what was in that variable. It's important to stress that hidden variables are all about access. When something is hidden, code inside the code has access to that variable. When something is hidden, code outside the class does not have access to that variable. They're forced to call methods to get access to the variable. To show you how hidden guards the value stored in an object, let's call setWidth with a bogus argument. So we'll go to our world reference and call .setWidth, execute this method, and pass it a bogus value of -2. What does a width of -2 even mean? That doesn't exist on a map. The United States isn't -3,000 miles wide. It's positive 3,000 miles wide. The width defines how wide the map is. The height defines how tall the map is. Having a negative width or negative height means the width doesn't exist. When this method executes, self will be set to the same thing the world reference is pointing to. So world and self will point to the same object. Now this parameter defines how wide our map is going to be. It would be kind of nonsensical to have a map with a negative width. This code will prevent that from happening. W greater than or equal to 3 and W less than or equal to 25. -2 greater than or equal to 3 is a false statement. If I add it together with a true statement, it's still false. So it's saying I do not like a width for my map of -2. Since this statement ends up being false, it will skip the indented code under the if and go to the code in the else. When the if is false, code will jump to the else. And that's exactly what's happening here. Do not change the width to a negative value. It'll print out bad width and tell you what the bad width was. Notice that the -2 was not assigned to __width. Instead, the code outputs bad width -2 to inform the caller -2 is not a valid map width. Look here in our object. Our valid width of 20 is still there. It was not replaced by -2. Now, why is this important? Well, let's see why it's important. Height is not a hidden variable. Everybody has full access to the height variable. Well, when you give everybody full access, they might do bad things. Height is a non-hidden public variable. It is easier to use. You can assign a value to height anytime you want. But look at the bad value. A -2 height is completely bogus. What does that mean if you have a map with a -2 height? It's nonsensical. But there's nothing to stop a -2 height. And the user can assign -2 to the height variable, and somehow the software is supposed to move on a map that has a negative height. I don't know how to do that. And it can happen on the other side too. Height is a non-hidden variable. It's easier to use because it's not hidden. You can assign any value you want to height. But look at the bad value. A 999 height is extreme. We're talking about large squares. We're talking about typing in, I want to go 3 squares left, or I want to go 2 squares north. You can't have a map that is so huge that it would take a person 100 years to navigate the map. You have to set some limits. The bigger the world, the longer it's going to take to play the game. So this bad value of 999, there's nothing to stop it. I was going to put a value in here like 40,527, but I didn't have room for something that big. But think about it. You're playing a game on a map. A map has to have a size. Can't have a negative size. It has to have a positive side. You don't want that map too small. You don't want that map too large, or the game will take too long. We need to impose restrictions on these variables. We need to be able to say it has to be reasonable. When a variable is hidden, you can enforce restrictions on the values by writing setters that do this. When a variable is not hidden, then all bets are off. You can assign whatever you want to the variable. Hidden variables guard the values stored in objects, preventing garbage in, garbage out. This is the oldest saying in computer science. If you allowed bad values inside your variables, you'll get garbage output from your program. If you prevent that, only allow valid values in your variables, then you prevent problems that will occur in the software. Static variables and methods. Before we get into static/class variables, let's review what we already know about variables. First, we know about global variables. Global variables, number one, are created outside of a function or class. They're at the top of the code. Here's a global variable debug. Outside the class, outside the function, this is a global variable. Number two, globals can be accessed in all functions and methods. This allows full access inside of functions and inside of classes. You can get access to a global variable. And number three, it exists for the life of the program. I already allocated and drew the debug variable on the screen because debug is created as soon as you run this program. Now, globals are different than local variables. Local variables are created inside a function or method. Anything created inside of a function is local to that function. Number two, locals are only accessed in their own function or method. When I create a local variable, it's good in that one method. And number three, locals exist only when the function or method is running. If I create a variable inside of a function, it's created when the function runs, and it's deleted when the function exits. The global variable debug is an example of something that is created at the start and sticks around as long as the program is running. Static variables and methods. Static, to put it simply, means no object required. That's the easy way to think about a static. No object required. Static variables do not require an object. They're created before the first object, and they can be accessed without an object. Static methods do not require an object. You can run a static method before you have created an object. Static vars are also called class variables. They are the same thing. A static variable, this one right here, and a class variable, that means the same thing in Python. However, static methods and class methods are different. This is the one inconsistent thing I've seen in Python. There is a distinct thing called a static method in Python, and there is something called a class method, which is completely different. A little strange that static variables and class variables are the same, but static methods and class methods are completely different. This is a simplified class enemy, so you can focus on the static and the class. There would be more variables and method in a full version of class enemy. Remember, I don't have a lot of room on these slides. I can't show you every variable that you would create. I can't show you every method you would write. So please bear with me. These are overly simplified slides, so I can show you what's important. As a static variable, one and only one copy of count will be created. If I created 100 enemy objects out of this class, just one single count variable would be allocated. So here I'm creating the class or static variable underscore underscore count. One and only one copy will be created for that variable. As an object variable, one copy of the health variable will be created for each object. Over here, I create a self.__health variable here. This is called an object variable. Every time I build an object, I will build another copy of this variable. If I create 100 enemy objects, I will create 100 copies of this variable. If I create 100 enemy objects, I will still only have one copy of the static variable. A static var means one variable for all objects to share. An object variable means one variable per object. That means it's non-static. I will get one copy of this variable for every object. Static variables are shared. Static variables allow objects to communicate with each other. If an object sees this going up, it knows more objects have been created. If an object sees this variable going down, it knows objects have been deleted. Static variables allow a way for objects to interact between each other. A static method can be run using the class. In other words, you go to the class name, the dot operator, to run a static method. I have a class named enemy. I could use the class enemy to run the getCount static method. A non-static method is run using an object. You have to create an object and then use the object to run a non-static method. So here on this line of code, I say E1 equals enemy. This will create an enemy object. Once I have the enemy object E1, I can use it to run a non-static method called getHealth. I didn't have room on this time to write getHealth, but it is not shown, but it is a non-static method. The @static is called a decorator. This is required for a static method. You have to put this line above every static method that you want to write. Also notice on a static method, we do not pass it a self variable. Remember, static methods have to run without an object, and you don't have a self variable until you create an object. Trace some code. Remember, static means no object required. I'm going to be able to run this method before I've created an enemy object. Static variable __count exists before the object has been created. When this line of code sets 0 into the count variable, we have created the variable before we built the first object. Means we will have an initial value in there without any objects being present. Send the current value of __count, which is 0, back to the caller. Notice how we're using the class to access the variable. That is a key thing to understand about statics. We use the class enemy to access the count variable. It contains a 0. We send that back to the caller. Complete the print command. Notice how it was done without an object. Static methods do not require an object. Static variable __count exists before the first object. We were able to call getCount and print count is 0 from the count variable here, all without creating an object first. Static variables and static methods do not require an object. That's why we use the class to execute getCount. Let's create the first enemy object E1. We'll run the default init constructor. E1 equals enemy. We'll jump to this code and execute init. When this is done, self will be set to the E1 value. E1 is a reference to this enemy object. Self will point to the same object E1. Self.__health equals 100. Each and every time I build an object out of the class enemy, I will build a health variable. Note that __health is an object variable. It's not static. Each object gets its own copy of __health, and E1's copy is set to 100. Recall when we called the method self equals E1 was set, so when I say self._health equals 100, E1's health variable gets set to 100. The static/class variable __count is not part of the object. It existed before the first object. There'll be just one copy of the count variable. And that one copy gets incremented by 1 and the 0 changes to 1. Here's the big difference between the two variables. __count has one copy and there will only ever be one copy of it. __health we'll get a new copy for each and every object that's built. The object E1 has been constructed. Return and execute the next line of code, which calls getCount. So after I built the first object, I will again go to the enemy class and call getCount and execute this code right here. Send the current value of __ count, the 1, back to the caller. See this return statement? It's grabbing the current value in the count variable 1 and sending it back to the code that called getCount. Complete the print statement. Notice how the value of _count is coming from the one and only copy of the count variable. The 1, which was returned, is printed out on the screen here. To really see how static and class variables work, we need to create more objects. Static variables are one copy for all objects. Non-static variables are one copy per object. It's going to be important to see what happens when we create this second copy of an enemy object. When we create E2, self will be set equal to E2. So anything that happens to self in this code will affect the E2 object. This is creating a second enemy object with the reference variable E2. Big fat note, _health is a non-static variable. Each new object gets its own copy of _health variable, and E's 2 copies is also set to 100. This is very important. I have created 2 enemy objects. With 2 enemy objects, I now have 2 object variables _health. A non-static variable means each object gets its own copy of the health variable. That's the big difference. With a static variable, there's only one copy of count. But as a non-static, there are multiple copies of health. Speaking of a static variable, _count is not part of the object. It existed before the first object. Adding 1 to the 1 copy of _count changes it to 2. So the constructor says, hey, I built a new object, add 1 to the count variable. And what does the count variable do? It's tracking how many objects we built. There's a 2 in this variable because we built 2 objects. Doing the print, the value of _count is coming from the only copy of the count variable. Also notice we're using E2 to execute getCount. We don't have to use the class. Once we've built an object, we can use the object to run a static method. To really see how static variables work, we need to create more objects. E3 equals enemy will create a third enemy object when it executes. Keep in mind, when we're building the enemy object, self will set equal to E3. So the same object that E3 is pointing to, self will point to this same object. This is creating a third enemy object with the reference variable E3. Here's the bottom line. If I've built 3 enemy objects, I have 3 object variables named _health. That's it. A typical normal variable created inside of init, you will get 1 copy of this variable for every object you build. If you build 3 objects, you'll have 3 _health variables. If I built 100 enemy objects, I'd have 100 copies of this health variable. What I don't get is 100 copies of the count variable. I'll go to the enemy class and access _count and add 1 to it. Third time through, we've bumped this count to 3. The bottom line on a static variable is if I have 3 enemy objects, I still only have 1 static or class variable _count. Doing the print, the value of _count is coming from the one and only copy of the _count variable. So getCount returns the _count. That 3 gets sent back, and the print statement puts it on the screen. What static methods cannot do? They cannot access object variables. I did this line of code in red because it's a bad line of code. Self.__health equals 10. Since getCount needs to be able to run without an object, you cannot access object variables. The other reason you can't do it is there is no self parameter. Notice how this has a self parameter. It can access object variables or static variables. Notice how this has a self parameter. You need that self parameter to access this object variable here. Without a self parameter, Forget about trying to access an object variable. If underscore count is going to truly track how many objects we've built, we also have to keep track of when we get rid of objects. E3 equals none will get rid of the E3 object. However, when we get rid of the E3 object, we need to adjust the count. So we're going to build a new function, a new method in here called underscore del, short for delete. What this is going to do is keep track of when objects are deleted. E3 equal none has executed and the E3 object is gone. That automatically calls this code right here. This is the delete function, called a destructor in other languages. Just like init automatically runs when we create an object, del, or the delete function, automatically runs when we get rid of an object. When it runs, we'll output the word gone on the screen to let the user know that an object disappeared. But then we'll go to the enemy.__count and minus equal 1, we will subtract 1 from the count variable. In other words, this function runs when we create an object, it adds to the count. This method runs when we delete an object, it will subtract from the count. Now there's multiple ways of deleting an object. The del command will say delete E2. Not only does it delete the object, it deletes the reference at the same time. When E2 is deleted, we will output the word gone on the screen again to let the user know a second object has been deleted. And once again, we'll do enemy.__count minus equals 1, and we will subtract from the count variable. This is called a destructor method in other languages. It runs when an object is deleted. There you have it. Static variables and methods are an advanced object-oriented topic. Once you start understanding static variables and methods, you're really starting to understand how objects work. That's it for this lesson. Goodbye and good night.